Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new series called Insular Industries. Here, we highlight some of the cultural blind spots that some mega industries have in certain web handling areas. In this final show of the series, we will critique the step and repeat and forms industry. We will cover tension control, path control, and other topics. I know your time is precious, so let's get started. Step and repeat machines are used in a wide variety of applications. Two examples are sheeting, such as used for food products, and roll to sheet, such as used in the forms industry. There are several reasons why these design configurations are popular. One is that it can separate continuous operations such as unwind paying out with stop-start operations such as sheeting. Another reason, mostly peculiar to the forms industry, is that the configuration allows separate modules to be made by different builders without the need for any of them to communicate with each other. This is in stark contrast to almost every other continuous machine where each module knows something, if not a lot, about what is happening elsewhere on the machine. Let us compare, contrast, and critique both the slack web and tight web applications. In the slack web design, shown in the top figure, the continuous or nearly continuous unwinding operation is separated from the downstream process by a slack web or a low mass dancer. The unwind need know nothing about what the downstream process is doing and thus is almost entirely self-contained. The tight web application shown on the bottom figure is different because, as its name implies, the web is tight everywhere, usually conforming to the 10 to 25% MD tensile strength guideline as taught in my Web 101 training and elsewhere. Also, best practices requires that the unwind not only know about its own diameter and its own torque, but also the line speed of the rest of the machine. If you compare the two designs, you will immediately see that the slack web design is much more complicated and more expensive, both mechanically and controls-wise. Specifically, we must have at least one extra drive to grow from zero or low tension of the loop to high tension required by the downstream process. Specifically, we will almost always need some sort of guide to clean up the web's path position. Sometimes this is a simple passive guide, such as edges. Sometimes it requires an active guide. In any case, these extra parts are required simply because the slack web operation broke several rules of web handling. This slide summarizes the pros and cons of the slack web and the much more standard tight web design configurations used almost everywhere else. As you can see, the pros of the slack web are primarily just one thing: no communication, mostly just a speed signal, is needed for a module. The cons are enormous. As we have already mentioned, a greater mechanical and control complexity, hence a greater cost. Now, we will mention, even when well done, the tension control will be some sort of awful, surging and plunging tensions with every single cycle. The good news is that it is trivial to design a new machine with Provision 4. By that I mean one that could be operated in tight web with the fallback of slack web if the mostly unjustified fears of the old-timers come true. Thank you so very much for joining me in this Insular Industries miniseries. This ends, for now, this wide-ranging critique of a wide set of industries. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything useful here, please like and share and subscribe. See you next time.